All right, aloha everybody. I'm here with Harry Durgan from Puna Weather. We're going to be doing a little joint collaborative update on Hurricane Erick and Tropical Storm Flossie. Both of these are back-to-back systems that are currently approaching the Big Island, but we're going to get a little more in-depth on this thing with Harry Durgan. Harry, thanks for joining us.
Oh, I'm glad to be here, Dane.
So let's start with the first thing right away. Let's talk about Hurricane Erick. As you see it right now on the screen, the one closest to the Big Island.
Here's Erick.
All right, the John Madden pin is in play. All right, so let's talk about Erick.
Okay, Erick is moving in west-northwest direction like this. Okay, and Erick looks to pass a good distance from the Big Island. The highest winds associated with Erick are located next to the center of circulation, so they're going to stay about here. But flow on the north side of Erick is coming in from the east.
Right.
And that's going to enhance our trade flow. And with abundant moisture associated with the storm, that means rain for us.
How about wind? Are we going to get wind from this thing, or what's your expectation?
There's going to be some tightening of the pressure gradient between the high pressure to the north and the storm to our south. So I don't see how we're not going to have windier than normal trades, but that's what we're mostly talking about, is windier than normal trades. We're not really talking about storm winds. Small exception could be down here in the Ka'u district. Because they stick out in the middle of the ocean so far, they might see some funneling of wind and could see higher gusts down there.
Anywhere else in particular along the south-facing shores, perhaps, or
maybe up in the saddle, because we normally get trade winds pinched through the saddle anyway. Okay. And so if we've got enhanced trade winds because of the lower pressure to the south and the higher pressure to the north, then we could see some enhanced funneling of wind through the saddle too. I guess it's possible to the far north up here near Hawaii, because we get funneling up there too, but to less of an extent than down in the Ka'u district.
Right, and it's an important note that this one's expected to pass well to the south, the center of this hurricane, which is surprisingly not really weakened in the past day.
Yeah, it's weakened, but not as fast as it was supposed to, that's for sure.
Right. Yeah. So what about a storm surge or anything like that associated with Erick?
You know, that's an excellent question. I don't see how we're going to escape high surf on our southeast facing shores, and the storm is stronger than it was supposed to be at this point, and I would expect that means we're looking at a good long period of warning level surf from the new beach of Kapoho all the way down to Punaluu and South Point, although South Point's closed.
Right.
They closed the road.
Yeah, the road's been closed except for residents, and also Po'iki, Punaluu, beach parks, as well as any other south-facing shores that I can't remember right off. They also closed.
Okay. I would expect surf down there to be 15 to 20 feet, some sets to 25.
Ooh. All right. So this one's Erick is mostly a miss in your mind, or is this going to have some kind of important impacts on the island?
Well, it's a miss in terms of wind, but I wouldn't call it a miss in terms of rain.
Okay.
As you can see, we've got winds from the south here, winds from the southwest approaching the storm and blunting the front of the storm. You'll see that there's a line here where the outflow doesn't go farther to the southwest, and that's because of these winds here approaching that are pushing a lot of the moisture towards the northeast. Okay, so right now that's pushing it this way, but as the storm gets closer to us, as a matter of fact, when it gets past us and the storm is located here, then that same wind pushes that moisture over us. So we're in the exact location to get tremendous amounts of moisture. So I'm going to say it's a direct hit as far as rain goes.
As far as rain.
Yeah.
Yeah. So kind of expecting, how much rain are we looking at, really? A few inches, a few feet, Hurricane Lane?
Well, Hurricane Lane had a unique situation where basically there was a big thunderstorm parked over our island.
Right.
Right. we don't have the same upper level cold air associated with this system that we had with Lane, so I doubt that we're going to see that kind of large mesoscale, large scale thunderstorm activity. I'd be surprised if we saw much thunderstorm activity at all, to tell you the truth. This isn't really that kind of a scenario. But we've got what we didn't have with Lane. We've got strengthened trades and plenty of moisture, so this is going to pile rain up against our east-facing shores, and then as the storm continues to move on, Kona side should get in on the action too. So I wouldn't be surprised if Hilo saw 3 to 6 inches, and some parts of the island a foot, maybe even some very select areas a couple of feet.
Wow.
Okay.
All right, so now I think we've gotten Eric kind of out of the way on this one. Let's move to more the potentially scary one, at least in my eyes, the tropical storm Flossie that's hanging out behind Eric coming in.
That's Flossie.
On the tails.
Yep.
So this one, the projected path as of right now has been kind of on the crazy side, has it not?
It has. Models are all over the place on this, and one of the reasons is that the system isn't behaving in terms of its intensity as forecast. And another reason is that it's so far out, it's hard to forecast what's going to happen with an upper level trough near the western side of our island chain over here. We're expecting activity way over here near the date line to influence the eventual direction of Flossie as it approaches our island chain, and the whole system is rather complex, and there's a variety of model solutions. Some of them go well to the north of our island. If this happened, we wouldn't see anything. I don't even know if we'd see rain. We certainly wouldn't see any wind. There's other models that go over our island, and there's other models that go south of our island. So right now, we don't know.
I think we should maybe show some of those models.
Yeah, let's do it.
All right.
Okay, this is the latest GFS run, and this one actually shows the storm coming very close. Now it's very, very weak at this point, according to this model, and this has to do with the way that the storm traverses over colder water on its way over here, and also how the shear interacts with the storm. But we've done a poor job of modeling the storm strength, so I have some uncertainty associated with the strength of the storm when it gets here. The GFS is our newest, greatest modeler of weather activity, but we also often look to the European model, and the European model shows the storm moving north well before reaching our island. See that?
Yeah.
So it gets nowhere near us. And the European model actually so far has performed better with Flossie than the GFS, and the National Hurricane Center is currently leaning towards the European model in their discussion. We have other models too. Here's a more local model, and this model, ends up with a very weak storm, but with a position that is actually south.
Right, comes in right into the island.
Yeah, so we have a variety of solutions. None of them indicate a strong storm at this point, but all of them indicate various solutions in terms of where it's located when it passes our longitude. Uncertainty is high.
Yeah, uncertainty is high with this one.
It sure is.
And you were also talking about how even the models, the same model within the past 12 to 24 hours has changed.
We saw that most with the GFS. Let's look at that. Okay. This is a high resolution model of the GFS, and this is the most current one. And it shows an approach that's about, 60, 70 miles off our coast.
Right.
But the run that was just before that showed the storm at quite a farther distance away.
So it's got
maybe twice as far.
Yeah.
So it's moved considerably closer. As a matter of fact, if we look farther back, we see a solution that has the storm very near our coast. So we're seeing a lot of variability even within the same model from run to run.
Right. It's very unpredictable out there right now. So that's kind of why it's a concerning storm. Yes, it's not that strong a storm, but as we saw in Hurricane Isabel, it doesn't take that strong a storm as long as it makes it a direct hit to cause havoc.
That's exactly right. That is exactly right. So let's look at Flossie. Here's an animation. And one of the things we can see is that this is the circulation up here. It's farther north of this convection. And this is the surface circulation. All the convection is located at the very southeastern quadrant of the storm. And this is due to very high stress coming in, I'm sorry, there we go. That's due to a very high shear coming in from this direction and pushing this convection off to the side. This shear is supposed to change and come from this direction and actually increase over the next day. So I don't know if Flossie's going to survive. If Flossie does survive, it is possible the shear will drop to the point where Flossie can either maintain its strength or maybe even strengthen a little before it gets near us.
So it's possible you get everything from sheared away to strengthening.
Yeah.
Even too. So that not only is it the projected path unknown, but the strength is unknown.
Yeah,
or
that's
has
true.
a high unconfidence associated.
We've got model solutions that approach category 1 or at high-end tropical storm all the way down to remnant low. So this is a tremendous spread.
Right.
Yep.
Incredible. So yeah, we'll be definitely watching the Flossie as Erick passes by.
Yes. I would like to look at these graphs.
Yes, please do. This is the punaweather.org site, yeah?
Yeah.
That you've set up to help display some of the data associated for the Big Island that
That's
you
right.
commonly use.
So this one shows pressure, and this is Erick. And this shows Erick actually holding on to its strength, which is amazing. We expected this pressure to keep rising here.
Yeah.
So that would have indicated a weakening storm, but we see here that the pressure is actually holding or even dropped a little bit.
Right.
The bearing is mostly west. This is really good for us. We don't see
Right.
any northward movement here.
No north is really good at this point. It needs to just keep going west, just get around the islands a little bit, then it can come north.
And we don't see much enlargement of the wind field either.
Right, so it's holding steady on its
Yeah.
radius. Awesome.
That is good. I like that. Okay. Cloud tops are starting to warm.
What does the cloud tops warming indicate for you?
It means that the convection, the thunderstorms in the middle of the system aren't reaching as high into the atmosphere. They're weaker. And this is a good sign of a weakening system, is when the cloud tops start to warm. All right, that's Erick. Let's look at Flossie. All right. Flossie looks like it's trying to hold on. Its pressure continues to drop.
Right.
Ever so slowly, okay? So it isn't dead yet, although I wouldn't be surprised if it did die. It's very consistent on its bearing. It's heading just north of west. So we would expect this to continue. Cloud tops have warmed recently, and I don't know that this indicates that the system's weakening or going to weaken to the point where it dies, and I'll tell you why. We saw cloud tops warm and then cool here, and a lot of this was at night, and at night the storm has the greatest difference in temperature between the upper air and the ocean. Okay,
All
so
right.
you're going to see more activity, and then when day comes,
It warms back up. Yeah.
it warms back up in the upper atmosphere, but the surface, because the ocean doesn't change temperature, stays the same. So you have less opportunity for
So it's
difference in
It's like
temperature.
a diurnal bump in tilt meters almost, where you get the little cycle from day to night where you can see.
That's
like
exactly what it is, Dan.
Yeah.
You nailed it. That is exactly. So part of that signal is on top of this. I don't know how much we can infer from these
Right.
warming cloud tops. We saw a tremendous amount of shear over the storm, so I'm surprised there's anything anyway. And as I have mentioned, if the storm just ended up dying, I wouldn't be surprised.
Right. And it's just such a wide range of possibilities. It
I
could
know.
be anything from dying in the ocean before it gets here and missing completely.
To a small chance of high wind risk.
Yeah, and a direct hit, like David said.
That's ridiculous.
Yeah, it's pretty bad.
All right.
Hopefully the models come to some kind of consensus.
Well, they will as time.
Yeah. Hopefully it's not like Lane where the models are disagreeing up until it shears away, and then everything comes unified. Like, oh yeah, it broke up.
Let's look at the shear. So here's the shear maps, and we can see how close high shear is to Flossie. See, we've got high shear up here, and this is based on, no, I can't use that. This is based on a jet stream winds up here, okay? And the storm is right near them the whole time.
Just hugging them.
Is it close enough to be interrupted? Probably. Is it close enough? Is it far enough to be away? I don't know. Maybe. So there's this in-between time this whole time. And then as it gets closer to our island, it's supposed to be a direct hit with this shear, which would rapidly degrade the storm. And this would be great news. So then it wouldn't matter where the storm went. It wouldn't have any strength.
Right.
And that's what we hope happens. And that's what they're forecasting right now. But
it shears apart.
as you can see, this is our jet stream winds. There's a trough here. Let's see. There's a trough here. And this trough really dictates where these high-level winds are located. Okay? So let's look at that as Flossie here approaches our island. I'll go back in time and we'll go forward.
It's approaching.
So we've got the trough digging,
right.
And as it digs, most of the higher level winds pull off to the north. How much of these winds stay down here is the question. See how they pull off to the north here?
Right.
Because of this digging trough.
So where does the interaction exactly start?
Where does it see? It's right on the edge.
Yeah.
I don't know, Dane.
And that makes a big difference for could make a few miles of difference type of thing in the end of it.
Might make a big difference.
Yeah.
Yeah.
So definitely we're keeping an eye on both of these. Erick, expect rain, not so much on the wind,
right.
Possible wind.
What we'll be watching for with Erick, and this is a real risk for us, is that since the flow is going to be almost continuously from the east, like trade flow, we could get training. That means where rain sits over one area and doesn't move.
Oh, some anchored rains, yeah.
Exactly, and those could really add up, and then we could have some flooding problems. So we'll have to keep an eye on just what you said, anchored rains. Good
right.
call. Yeah. And then, of course, with Flossie, our greatest question is, where's it going?
Mm-hmm.
Uh-huh.
Where is it going, and how big is it going to be when it gets there?
Yep.
Or will it even exist?
Or will it even exist?
And it's only a few days out. When is the expected arrival of Flossie?
Monday.
So only a few days out from it passing, and still a high degree of
Uncertainty.
Uncertainty, yeah.
This is at the higher end of uncertainty. We've had uncertain storms before, but this is one of the more uncertain ones right now.
All right. Well, we'll keep an eye on it, and thank you for joining us and giving everybody a little bit of an explanation on this whole thing. Check out Puna Weather if you haven't subscribed or joined already. And yeah, thank you for joining me, Harry.
Dan, I really appreciate your time. All right. Bye,
All right.
everyone.
Aloha.